everybody! Today we are going to be going on a really exciting field trip to Goldstream Provincial Park. Goldstream Provincial Park is on the traditional lands of the Coast Salish, Wisconsin, and Longese people, which means that for many generations, people have been learning and living on the land that we're going to be visiting today. Before we leave, everyone should double check that they have all their things, including the reflection sheets, photo scavenger hunt sheets, and the Goldstream Provincial Park map. Chaperone should also have a copy of the Real River Rapids quiz sheet and an outline. Have you got it? Perfect. Let's go. Hey everyone, welcome to Goldstream. Before we start with our activities, I want everyone to have a chance to explore and connect with the nature we have here. I have set out cones around the perimeter, and you have 15 minutes to explore as long as you stay within those cones. This is a great time to start your photo scavenger hunt or use the bathroom. I'm going to blow the whistle in 15 minutes, and then we're all going to meet back at that bridge. Okay, wow, great. Thank you for getting back so quickly. Did you enjoy exploring Goldstream? Fantastic. Did you find things on your photo scavenger hunt? Amazing. That photo scavenger hunt is going to be ongoing throughout this whole day. So if you see anything going on at any point that's on your list, just stop and get a quick photo of it, okay? Okay, now we're going to start with our first activity, the Real Rapid River Quiz. Now I know the word quiz is a little scary, but don't worry. This is just about engaging us with our environment around here and also to get us thinking about that information that we've already been over in class. So the first thing we need to do is come up with names for each side of the river. Does anyone have a good name for this side of the river?
Tulip.
Tulip? That's perfect. Okay, this side of the river will be Tulip. Now, does anyone have a good name for this side of the river?
Daisy.
Daisy? Amazing. This side will be Daisy. So our sides of the river are Tulip and Daisy. Okay, great. So how this activity is going to work is I'm going to ask you a river-related question with two possible answers, and we're going to assign one answer to each side of the river. And then I'll ask you to stand on the bank of the river with the answer you think is correct. So, for example, if I asked you, is Goldstream fun? Stand on Daisy if you agree, Tulip if you disagree. I would hope you'd all be here. Okay, our first question is, can you see a meander in this river? Stand on Daisy if you think there is, on Tulip if you think there isn't. You're right, there is a meander in this river. If you look up here, you can see the river curving slightly, and you can see it more if you turn that way. See how you can see the bends in the river? That's the river meandering. Because there is a meander at this point in the river's path, there must be a meander all the way from its source. Stand on Daisy if you think this is true, Tulip if you think it isn't. You're right, just because the river's meandering here doesn't mean it's meandering all the way from the source. In fact, today we're going to see different river channels right here at Goldstream. And there's lots of different factors that affect the type of channel we see in a river. The topography and the velocity of the river and the sediments that are in the river all affect what kind of river channel we get. Here we have a meander. Up higher in the mountains, we might not. It all depends. Now, which side of this river has a cut bank? Tulip or Daisy? You're right, this is the cut bank. The cut bank is a part of the meander that is eroding. And you can tell it's this side because on that side, you can see all the deposition. Here, we see the river is moving faster and cutting away, hence a cut bank. Now, in which side of the river would the water have a higher velocity, Daisy or Tulip? You're right, this side of the river does have a higher velocity. The cut bank, or the side where the water is running faster, would have the higher velocity. This is where the erosion is happening, where the water is moving quicker. Over there on that side, the water is moving slower, and that's what leads to the deposition.
Okay, final question. Who's ready for the tour? Stand on Daisy if you're ready, Tulip if you're not.
Okay, great. Let's go. Okay, here we are at our first river feature. Can anyone tell me what feature we might be looking at here? right, a meander. I heard a couple of good answers there, and there are a couple of river features at play here, but most simply, we're looking for a meander. As you can see, it winds down here and makes curves all the way down the river. And like we said in our game, just because it meanders here doesn't mean it's meandering anywhere. Can anyone think of one good reason why the river might be meandering here, but not, say, up higher in the mountains? Topography! That's a great answer. Yeah, in the steep mountains, the river is rushing down and being pulled by gravity in more of a straight line. But here, we can see the river moving back and forth because it's a little flatter around here, so it has that freedom to do so. Okay, here we are at our first river feature. Can anyone tell me what feature we might be looking at here? That's right, a meander. I heard a couple of good answers there, and there are a couple of river features at play here, but most simply, we're looking for a meander. As you can see, it winds down here and makes curves all the way down the river. And like we said in our game, just because it meanders here doesn't mean it's meandering anywhere. Can anyone think of one good reason why the river might be meandering here, but not, say, up higher in the mountains? Topography! That's a great answer. Yeah, in the steep mountains, the river is rushing down and being pulled by gravity in more of a straight line. But here, we can see the river moving back and forth because it's a little flatter around here, so it has that freedom to do so. And do you know what the side where the erosion occurs is called? A cut bank. You're absolutely right. And here we are standing on one. This is a cut bank where the river is still eroding this side and bringing the sediment, the rocks that we're standing on, might one day be in this river, being drawn downstream to be deposited at a different point bar. We can think of meanders as when the river starts to erode a little bit more on one side, and then that little bit of erosion lets the water start running more and more and more onto that side, creating a higher velocity on that side and more erosion. And when all of the velocity moves to that side of the river, what happens to the other side? There's not as much velocity there. So that's why we get the deposition, the slower moving water on one side of the river and the faster moving water on this side. And that creates that zigzag pattern that we get in meanders. Okay, perfect. That's it for meanders. Let's move to our second feature. Come on. Okay, I'm cheating a little bit here because the best way to really view this feature would be if we could zoom out and look at it from above. Can any of you think what that feature might be that we're looking at here? A tributary stream. You're right. Now, why don't all of you take a minute and look at your maps and mark down any tributary streams you might see that feed into Gold Stream River. Now, which would be bigger, this tributary stream that we see here, or the river that it feeds into? You're right. Tributary streams are smaller than the rivers they feed into. About earlier when we talked about origins of water. Not all the water in the river comes from exactly the same place. These tributary streams show that. These are bits of river that are coming from different areas of the mountain than the origin of the original river, and they feed into the river, all coming down from gravity on these different slopes alongside the river and feed into the bigger river that eventually feeds out into the ocean. And that's tributary streams. They really show us how interconnected our water systems are. Now, let's go take a look at one more feature. I think you're gonna know what this one's called. Okay, and here we have our next feature. I'll give you one guess as to what this one's called. You're right, it's a waterfall. And this one is actually called Niagara Falls because it is the same height as the famous Niagara Falls in Ontario in the US. This one, though, has slightly less water running down it. Now, if you had to pick, where would you say the ground is harder? The ground that we're standing on here, or the ground up at the top of that waterfall? Which one do you think is harder? Yeah, you're right. The ground up there is likely harder than the ground down here because one of the reasons waterfalls occur is when the ground has different hardnesses and erodes at different rates. If the ground here is softer and erodes over time, eventually it is much lower than the ground up there, which is much harder and not eroding as quickly. So we get this steep drop off as the water flows down that waterfall. So perfect, that's waterfalls. If you want some more details on it, look at the diagram in your notes. Now we're gonna head to our final river feature. Okay, and here we are, our final stop in the tour and our final river feature. Can anybody guess what feature we're looking at here? That's right, an alluvion fan. Alluvion fans tend to form near the end of rivers. And as you can see, we're nearing the end of this river. You can look out and see where it feeds into the ocean out there. Now, can you think of any differences in the river here at the alluvion between where we looked at the meander? There are a couple of good answers that you could give. Growth? That's a great answer. Yeah, here at the alluvion, we can see lots of life springing up on the river. That's because alluvions are fertile deposits of soil that have made their way out into the river. So here we see growth popping up as the fertile soil the river has brought down here is letting all of this grow out here on the alluvion fan. The speed, that's another good answer. Here we see the water moving a lot slower than we did up at the meander. One of the reasons that the water is moving really slow here is the topography. When the ground is flat, there's not as much gravity pulling on the water, making it go so fast. But as we discussed in the meander, the topography was pretty flat there. So can you think of any other reasons why the river might be moving slower out here? Yeah, you're right. The river's kind of overflown its banks here. So without the kind of strict reflection of the banks, the river has the freedom to move a lot slower. And the final reason the water is moving slower here is linked to the growth that's happening, these fertile soil deposits. We have all of this sediment. The river's kind of bogged down and moving a little bit slower. And I told you we were going to see some different river channel types today. Here, this isn't exactly a meander. This is more what we call a braided river channel, as the river kind of flows amongst itself in different patterns because of all the sediment causing the alluvial fan. Okay, great tour everyone, and thanks for participating so much in our fun river excursion. Now we're gonna have 15 minutes for you to work on your reflection sheets, finish up that photo scavenger hunt if you see anything, and use the bathroom and get all ready to get back on the bus and head home. Thank you so much for such a fun afternoon.